Okay, I'll call the annual meeting of the shareholders of 2025 to order. Okay, here's the agenda for the 2025 meeting. We're going to call it order. We're going to summarize the 24 operations, go over financial status, shareholder questions, and then voting and adjournment. So here's our illustrious board. And then so in April 10th, 2024, we had a situation where we were informed by our former landlord that we had to vacate the premises, irrespective of us having a lease to the end of December. And we were looking at many different facilities. We had two superb facilities we were looking at Newtown, but we didn't have a lease. And then we were working on floor and infrastructure plans, build out, cost analysis and the like. And we were starting to pack up. And we found that we found an ideal place, the current facility in Newtown, Pennsylvania, 105 Terry Drive. We looked at many different sites in Florida, Texas, New Jersey, and Pennsylvania, and it turns out one of the sites we almost signed a lease on in Clearwater, Florida, it was actually underwater. Like 3 times since we looked at leasing it, so it's kind of fortuitous we didn't move there. So this is actually a really perfect location. We have 2 loading docks, 2,000 amps of 480 power. We have 6,000 pound, like 60 square foot dock lift. We got 3,500 square feet of Class A office space. It's just beautiful for a lab in terms of the layout and the capabilities we have here, and it will suffice very, very well through the IPO that we have on track for. So I'll explain. So it took us a lot of work and a lot of people and a lot of hardship, and went through a lot of people doing the moving. We had to take out 20 years of house cleaning. We had, I think it was like 30 dumpsters. They're like 30 cubic feet. And here's a picture of where we were on March 11th. And we actually ended up filling the entire building, the entire 10,000 foot footprint we had then with materials and equipment and the like. We had an inner contract that we had for lease, and that lease was signed on May 24th, and it was very, very fortuitous that we procured a facility, or else we would have been out of business. So we were only given a couple months to move and get out, vacate the premises. Apparently the fired landlord had a theory that the building wasn't under zoning because it was built pre-zoning, and even though it had been used for 20 years by us for research and office, which was currently zoned, and the landlord was the landlord was probably misinformed, because the township mayor is the hardest mayor in the state of New Jersey, would understand in terms of approving anything in terms of a variance and the like. So nonetheless, we had sort of no option other than getting out. And then in the lease, it had a sole source contractor that was pretty adamant about doing an entirely different model of what we had in terms of a lab facility, and doing a warehouse build out, which would have costed about $500,000 above what we had anticipated spending. And now we had to spend above what our TI allowance was, which was about $260,000. So then the contractor refused to open up the building from the time we signed the lease until August. And we got the point where it was a dire situation. So I convinced the then owner of this building to allow us to do the demolition and open up the building. So we opened it up ourselves on August 1st. And then we started rolling trucks from August 7th to the 16th. We ran 14 trucks. And then I ended up being the general contractor in many, many other roles, doing egress plans, architectural plans, electric, all the different things. And we ended up doing most of the work here that you see in the facility ourselves. And then Brilliant was doing the moving, the cleanup, which was actually a lot, because there's still a lot of things to take apart and decommission alike. So the last truck from Brilliant was August 24th. And then to make this whole facility feasible, while ripping out all the infrastructure and this legacy infrastructure and the like, was I invented a new ceiling, prototyped it, And you can see that in the lab now. It's actually expanded metal aluminum mesh that takes the sprinklers and the smoke detectors up to 18 feet. And actually, everybody really loves it because you don't have to do engineering plans and on the sprinklers and hydraulic studies and the like. You can just move walls wherever you want, and it's very, very versatile, and it solves our problem of having the really intense power of the SunCel uh, away from the sprinklers, so they don't set them off. So it saves an enormous amount of time. We'd probably be here like another year getting into the facility, not an enormous amount more money. So this is our last truck, and this is the ceiling, and this is what it looked like before we started. And it came a very, very long way. So once we moved in, you can see on the right here, there was no place to move. I mean, we literally covered like every square foot of the facility, and we were moving equipment back and forth, trying to do every imaginable aspect of it in terms of floor installation, fires, electrical alarms, case where everything we needed to make it into a lab. So then I got this idea just buying these a massive number of pallet racks. So I went on an auction site and bought 80 sections of it, and we got a truck and we headed up to Pine Brook, New Jersey, and we tore them all down, 18-foot racks, and we load them up in the truck. And you can see here, this is after I was cleaned up. We went through about 3 masks a day each. It was just a very dirty job because they were covered with toner or some sort of soot, and we power washed them off, cut them, and put them together, and we finally cleared the floors and made some progress in terms of moving. So then we went up to East Windsor from Braco and bought a massive amount of furniture and beautiful stuff, and we moved it ourselves, and that was in January. This January 24th, this picture was taken. So then we had about $260,000 tenant improvement allowance, so that we used minimal amount of it compared to what we're anticipating if it had been about $750,000 if we'd done all the things that were on the original contractor's plan. So we did about 100,000 of it ourselves, and we got our certificate of occupancy issued on the 24th of February, and then we finally received the official notice on March 1st. And it was amazing, major slog in terms of fire systems and fire alarms and sprinklers and on inspection after inspection. And but we finally managed to do it, and it was really something we were extraordinarily excited about because it's actually hard to get hydrogen permitted and the type of applications we're using. I couldn't get it anywhere in New Jersey. And it was a good situation for the company in terms of where we are now, and we're really in a good position in terms of our facility and infrastructure. We didn't have any people. We had like 2 people when we moved out because we were packing up. It's hard to hire anyone where we didn't know where we were going to go. So now we went from like 2 people. We have like 11 plus Agata, my wife. She's here like full time for more than a year now, and she does all our hiring and runs all over the country, picking up materials. She goes to Home Depot about 2 times a day, and then goes up to the CMF and goes up to Newport and all kinds of different Ramel and picking up equipment and down to NDS for glass and all the glass products and like. So she's always on the road and helping us out, and we really appreciate it. We hired an expert in analytical, and we got tremendous breakthrough there. And we've also did a bunch of laboratory purchases, accelerate the Hydrino analytical and validation. So now on to the SunCel. SunCel is a dual molten metal injector. It has 2 molten metal streams that intersect, and then there's a high current that goes through that, ignites plasma, which shouldn't really exist. And we get a tremendous amount of power from that, creating this new state of hydrogen called Hydrino. And then it has something called a dense receiver array, which is assemble photovoltaic cells that go around the light emitting dome and convert that high intensity light into electricity. So we have a direct electric system that does not require transmission or distribution or demand charges associated with it. And it can do DC loads or go into inverter and supply AC as well. The other aspect about the SunCel, it has a gold atomic layer on the back of the photovoltaic, so it can reflect the unconverted light back into the plasma and have it recycle, which dramatically decreases the thermal load on the PV cells and the heat rejection requirement, and it'll give you tremendously high efficiency, and that's been proven by Caltech, MIT, and Cal Berkeley. It's something I filed patents on quite a while ago, and it's been confirmed. It doesn't give you percentages increase. It gives big multiple increases of efficiency. So then another issue we tackled when we moved in, we found due to zoning and safety and just logistics, we can't have an overhead crane or winch and take the furnaces up into the ceiling with the type of scenario we have now, plus just the safety issue of hydrogen source underneath this dome it could be a hydrogen trap at 1400 degrees centigrade, can't thaw wires, not a good combination. So we replaced that with inductively coupled heaters, and also called induction heaters. So they have antennas, and they basically have RF, like somewhere around like 20 kilohertz, and they induce currents in the material and cause direct heating. They can be extremely efficient, like 95% efficient. And of course, there's a lot of issues into getting that to work, to melt the tin, which you can imagine this is all solid, and there's a lot of different parts here where it could remain solidified, and we had to get it molten everywhere in order to inject and start a reaction. So it's quite a tour de force to do where the coils go and the geometry and impedance matching and how to distribute the power so one part didn't melt through and the other remained solid and the like. So there's many iterations of that, and then there's the different cooling systems, and then I invented a new type of switch, which the vendor did not think would work, but actually it works incredibly beautifully, and the impedance is pretty much unchanged because it's a parallel design, and it heats everything up extremely fast to get the cell going. For example, it's about 50 times more efficient in terms of energy than the kiln, going from 6 hours or down to about minutes with a third of the induction coupled heater power deployed to run the heat up cycle. The other issue is we did some antenna modifications so we can reuse this. They'll slip on and off, so they're reusable and detachable. So then it's very, very cheap. It's something that can be used very, very conveniently commercially. That was the whole idea. And then all these switches can be automated. It turns out like a electromechanical device for raising and lowering windows in a car is only $5, which is unbelievable, but that's what it is. And you can use those kind of mass-produced parts. Lithium-ion battery only need 4 kilogram. It's about $100 IGBT is all you need in terms of a switch. It takes DC power, which we produce by the SunCel, and converts it into this RF power, and then drives the induction heater. So it's a beautiful design, beautiful technology. We can use it for cooling as well, and I've had patents filed on that as recently as last night. So let me on here. So then where were we in April of 2024? It turns out that we had achieved an operational prototype. We had about a 20-minute run, 10x gain. We were using the Thor S322C photo power meter, photo detector power meter, and it's extremely accurate, like 1% of our entire range from like 200 nanometers out to 2 microns. It's a very good device. 40 kilowatt power level. Weren't running it too hard because we ran it harder. It mirror over the dome. So what was happening there is the tungsten electrodes, which you can see here, heavy tungsten electrodes, would get so hot they would vaporize, and then the metal vapor would deposit on the PV dome, and then that would be sort of the end of the game, because once it's mirrored over, all the light would reflect back into the cell, and you couldn't transfer the power. To give you an idea of the powers involved, we measured the plasma black body temperature at 5,000 degrees Kelvin and higher. which is about 50 megawatts per square meter. And that was so the main challenge we had with prior designs is they would melt very, very quickly. And we had one device where we had a window at the top of the cell, and then we tried to use some sort of parabolic reflector scenario and design to have the light go through the top window. Commercial windows is quartz. It melts at about 1600 degrees centigrade, and we had so much light going through it, it actually melted it and sucked it in before it could even melt the solder that holds it in. And the solder fails at about 400 degrees centigrade on a commercial window. So it was a challenge on how to seal this, and there really wasn't any technology. We went to Rayotech, we went to SHOT, we talked to CTO, COO, we talked to their CFO, their head of innovation, and anybody we could in the industry about solving this sealing problem. And we have really beautiful design about that, solve that problem. And then we can transfer the light out optically. The power out optically is light, but the issue was still metallization of this dome. And so I invented a number of designs, something called diverter cell, and another one I'll just call the dual pool design for simplicity. But it was not built and not tested at the time that we had the shareholder meeting last year. So there's big engineering challenges. You can imagine something that hot. It's hot as the surface of the sun, extraordinary power density. And we're injecting molten metal, which can alloy with a lot of physical other metal structures. It can vaporize pretty much any element it comes in contact with in the cell, and then that metal end up on the dome eventually because it's cooler and it'll condense there, and then it will metallize over. Even if it's not cooler, it will eventually end up on the dome and deposit there because the dome is certainly going to be cooler than the metal vaporization temperature. So at the high power is a good thing because it makes it superior to any other power source, but it's in a realm where no one's really engineered anything like what we've done before. There's no roadmap for the challenges that we have. So the current design is called a diverter type cell design, called it diverter, and it has dual molten metal injectors as before, powered by low voltage, high current DC. And the injector tips, again, they're also the electrodes as before. We had tungsten involved in the injection in terms of the final part that's in contact with the molten metal before it enters the plasma. But it's different because it's recessed such that the electric field from the plasma and the plasma is prohibited from contacting the nozzles because of the way it's designed. It screens it out. So this was a screen out kind of design. Was the theme there, and it actually works extremely well. And it's the same principle if you have being in a car during a lightning storm, and it's called a Faraday cage. Your car is a safe place to be in a lightning storm because the metal will conduct the electricity out around the car. So in this case, plasma is sort of like lightning. They have the same kind of properties, ionized state of matter, and it shields the electrodes. The only other thing that will destroy them, as we found, is if you go to absolutely massive amounts of power, they can melt. It can melt, and but they're very easily replaceable. It's only melts on the positive side where the hydrino reaction is dominant, but they're easily replaceable, and we probably aren't going to run it at that kind of ludicrous sort of power level anyhow. But it's just good to see, no matter how hard you drive the system, it does not get destroyed, and that is something that is kind of new to our experience because every time we run it like that, it would burn holes in it. I mean, it would just cause an incredible amount of damage and metallization everywhere and the like. And so it was a joy to the heart to see that this actually worked. So then the other design, which I believe is absolutely impossible to get metallization of the dome, is that we have actually pools of metal that inject it's actually a very elegant design, pools of metal that actually inject the molten metal. So everything's molten. So it's It's really a beautiful design. And we tested it out in terms of the systems that are really important that would cause electrical disconnect between the backflowing stream and the supply of molten metal to the injectors. And it actually works very, very beautifully. So I'm very excited about that. We have 3 of those in the build right now, and they're gonna go into the full cycle of testing here very, very shortly. So, but it's come a long way. I mean, I think this is sort of the final design. At least that's what we're anticipating. There's one other problem that I think was probably the most problematic. I mean, a frustrating problem of anything we've ever dealt with. I mean, I think we probably lost maybe 3 years over this issue. Like every time we would test, or pretty much every failure other than burning a hole in it was because the electromagnetic pumps failed. And I went all over the world looking at rotating magnets. I looked at mechanical. I looked at the induction type, AC type, all types of type. We even built an AC phase lock to induction type pump. It works, but you have to make it all out of ceramic, and it's very fragile. And then you have ceramic to metal unions and getting those to seal, and the thermal expansion and the fragility of that, and like it was pretty daunting challenge. So but what we have now, I invented something that actually seems to work, and I'm kind of holding my breath that this is it. But it does look like it. We haven't had a single electromagnetic pump failure, and we probably did about 20 trials, and we actually poured oxygen into it. And if you got any oxygen at all in the cell, that would be the end of those pumps. So it seems like it really works. It's a new design, and I think we may be clearing our biggest obstacle with that innovation. So of course I have patents filed on that. In addition, I have a German company, and they just emailed me again. They saw our video, they were really excited about it, and they really want to help us make a commercial product. They were on site about 3 weeks ago, and they're designing an induction type. But even in any case, I think what we have will suffice to go to commercial and be. It should be sufficient to last for 20 years. I mean, these pumps last many, many, many years. It's just no one's ever run them on conditions where you can have a source of oxidation. Same with these inductively coupled heaters. They're known to work 60 years maintenance free. They're changing the windings in them. So the parts we're using now, they're really good. I mean, these induction heaters should work. The electromagnetic pumps should work. They're like 60 years, like I said, decades they work, maintenance free. So all this stuff it should be pretty phenomenal in terms of doing commercial deployment. So here's what we're thinking. We had buckets and buckets. I mean, we literally had dumpsters full of cells that we go through. We had pump tubes, and I made a design where you could cut them off and put a plate and then weld them on, because the metal inside the cell would alloy as you welded, and so you couldn't get the metal in contact with where the weld was occurring. So I designed a way of getting around that. But we had cells that had like 5 plates. I mean, they're like getting inches thick. In terms of repair after repair after repair with electromagnetic pumps and burning holes, and many, many repairs and changes and things like. But it looks like we're not having anything break right now, which is a miracle for us. That it's a very, very good sign, because now we can focus on testing and running more toward all the different things we have to do to make it into a demonstration for companies, but more or less get all the parameters we need for commercial packaging, and focus on that packaging and commercial fabrication, and then work on SunCel assembly operation. We can scientists, businessmen, instead of spending massive amount of time on machining and drawings. I mean, we have thousands and thousands of technical drawings, and it's just an enormous amount of work with going to vendors and machinists and just getting the procurement of all these different parts and the fabrication alike. So we solves our supply chain issues. Okay, so we procured a large inventory of parts, and so we have two major assemblies now. We have what we call an exterior reservoir assembly, and you can see here a collar, and then we have an inner reservoir assembly. You see a collar here, and the two mate to each other. So we have parts that we can take apart and assemble and disassemble and take out different things. And then there's components that go onto this part that allow you to have the antennas go on and off, and also attach the ignition system and things like that. So let me go on to the Hydrino product confirmation. This is a major announcement, major news. So first of all, if you look at the video, we have a video of the SunCel on our webpage. You see this, there's a white smoke that comes out of the cell. Whenever there's a huge surge of power, you can see this kind of smoke rising. That's actually Hydrino. And the it's permeating through a 4 millimeter thick quartz dome. We see the same type of phenomena when we're doing a metal oxide in the atmosphere. We have a zinc wire detonation, and then this is what this is. And the metal oxide particles are polymerized by the Hydrino, and they form these web-like fibers. And I invite you to see this video. It's fascinating. You get these web-like fibers out of transparent air, and they just form and float in the air, and eventually form this web material that we do a lot of analytical tests on, like electron paramagnetic resonance and Raman and other things, and you can prove that it has Hydrino. So this is Hydrino coming out. We have a video on our archives. You go into archives on plasma videos, you'll see where we show a live, at the time, live demo. We videoed it of collecting Hydrino gas from the SunCel cryogenically and putting on and showing we have a new form of hydrogen. That was difficult to reproduce because we had to run at different pressures to maintain the SunCel. But then if we ran at too low a pressure where the SunCel like to run, then we would vacuum draw off the gas we were trying to condense. So it's kind of a tricky experiment to do. But now we got something that's absolutely 100%, and it's not requiring a SunCel or a cryogenic system, which is actually, cryopump and all the different support for that. That device goes down to liquid helium temperatures. It has it's a chemical compound, and chemical compound, you can add acid to it, and you can release Hydrino gas, and that is a way we can send Hydrino gas to anyone in the world, because we can send them the physical compound, they add acid to it, and it releases the Hydrino gas on demand. And here you can see it here. And this is hydrogen, and this is what they call ortho and para form of Hydrino. That is a signature that clearly identifies it is hydrogen, because there's only one type of molecule that has two spin isomers, and that's hydrogen. And what's unique on it is the iron catalyst. It's known that ordinary hydrogen interconverts from the ortho to the para form. And that happens with this as well. You can see this is all para form after it's been standing on a iron catalyst. So the other issue about this is the peak is faster than ordinary hydrogen. It comes out at an earlier retention time. And there's no known gas that comes out before hydrogen on a molecular sieve column. So this is absolutely definitive proof that it's some new form of hydrogen gas, and it is hydrogen gas based on the orthopara spin isotopes, nuclear spin isotopes are seen. So the important thing is that hydrogen is always the fastest gas on a molecular sieve column until now, because it's the lightest and it is the smallest, small and light. That's what molecular sieve, it separates by size and mass. So hydrogen has been the fastest, and now there's something that comes out before hydrogen. That actually proves that it's a more smaller form of hydrogen with the spin isomers that are observed. So we have many other data on this. This is unique because we ran 5 different analytical tests, and they all are complementary and prove Hydrino. We did Raman spectroscopy, and Raman is where you shoot a laser into your specimen sample. Okay, so the Raman spectrum is, again, we're looking at scattered light from a laser. It is what it is. All right, so typically a Raman spectrum, you see peaks very, very low energy, because basically they get energy higher than laser, which this represents in terms of this side of the spectrum. It's called the anti-Stokes side of the spectrum. you need to have energy higher than the laser, which is typically the laser energy plus any thermal energy, and the thermal energies are very, very, very small on a relative scale in terms of emitting light. For example, it's 11,600 degrees for every electron volt. So, the typical vibrational rotational energies you're looking at in terms of excitation by this Raman laser on the order of hundreds of electron volts. It's you're not going to be exciting anything with unless you get to extremely high temperatures. So it'll be in the thousands, so 0.1 to 0.01, so it'd be like 1,000 degrees to get anything excited. To see anything in around the 100 reciprocal centimeter range. So in this case, we're seeing out the 8,000, which is almost twice the energy of laser. So what's going on here is the hydrino uniquely can absorb 2 photons. This is 2 photon emission. This is not scattered light. This is actually, 2 photon absorption and its emission of those 2 photons. You're seeing 2 photon energy emission. And then you're seeing the first order, second order, and third order. So this proves 2 different things. It proves that you have some remarkable new molecular species, and also this fine structure matches the fine structure in the electron paramagnetic resonance spectrum, which is definitive of and identifies hydrino. So these are actually fluxon linkages, because the molecular hydrino has a paired and unpaired electron in the same molecular orbital. So you're getting this characteristic pattern of absorption, which incidentally, while I'm on this, it indicates you can make this particular molecule into the binary switch for a photonic computer. So there's things called superconducting quantum interference devices that Google is using, called quantum supremacy, where they're trying to use these shoebox-sized devices that operate at almost absolute zero, incredibly cold temperatures that they have to keep in a cryogenic container and the like. And they're trying to have the same sort of phenomena with this electronic device that you can replace with a molecule that is a million, trillion times smaller and operates at extremely high temperatures, doesn't need cryogenic temperatures to show this phenomenon. So it's got tremendous applications, and other applications too, super magnets and other things I'll talk about. But it does show you can undergo 2 photon absorption as a unique phenomena, and that has implications for a telecommunication system that I'll describe. This is another type of test, like electron beam excitation. You can see these beautifully evenly spaced lines. These are the rotational energy lines of molecular hydrino. And then here's the electron paramagnetic resonance. Again, absolutely definitive of the structure. It's showing that there's a paired and unpaired electron. The unpaired electron is responding to the electron paramagnetic resonance spectrometer. Otherwise, you wouldn't see this signal. So this is the spin flip transition, and then there's a paired and unpaired to have something called spin orbital coupling between the paired and unpaired, and causes this splitting and the number of multiplets. And then within the multiplets is this phenomena where the electron it's called linkage, where it basically is absorbing a unit of magnetic flux of magnitude h over 2e. It's called the magnetic flux quantum. And so it's not continuous. It's not a continuous. It's quantized, and you get these multiplets from that. And there's nothing seen like this. And this is the exact solution from my theory. I solved this exactly. And this is what we observe experimentally. And you can't do this with quantum mechanics. Quantum mechanics is just a bunch of curve fitting, where they just take the data and then they have a bunch of parameters they fit to the data, and they say, well, this is from this phenomenon, that phenomenon, but they can't analytically solve it or predict what the spectrum will look like ahead of time, as I've done here. And that's what it sounds like if it were, actually put into a sound, which is kind of sounds like a heartbeat, which is pretty unusual and nice, but familiar to people. So the new development is that this hydrino can form dimers, and ordinary molecular hydrogen can form dimers at very low temperatures, cryogenic temperatures, but the hydrino can form dimers at very high temperature. So this spectrum that you saw before, this is what it looks like on the same scale as this new form of dimer molecular hydrino. And it causes what they call a downfield shift, about 500 Gauss. That was predicted, and we observed that. And the other interesting aspect of it is the dimers can form tetramers that side by side pair, and it eliminates this signature. Now this is actually two spin has two spin 1/2 molecules that are bound end to end. That would cause a very different spectrum, except that it's forming dimers. That's this characteristic of identifies as a dimer, and then the dimers actually that signal actually disappears. It vanishes at a certain temperature that was predicted around 100 degrees Kelvin, and then it reappears once you go above that temperature. So we've got really beautiful data on the dimer characteristic. So, and also we've seen the 1/8. So we've seen the 1/4 dimer and also the 1/8 quantum state dimer, which indicates we can make 4 times or about 800 times energy combustion from making hydrino versus what we had shown previously with 1/4. And I'm sure you can go down to lower and lower energy states, and I'll talk about the implications as the hydrino goes down to successively lower and lower energy states. What happens to it in the end? I mean, what is the end state for hydrino? That was a big question that I answered this year, which is very important for a lot of things, as I'll describe here as I go forward. The other thing is very interesting about forming dimers is you can have ordinary molecular hydrogen form a dimer with hydrino, and that can transform an ordinary salt into a hydrogen storage material, which is pretty phenomenal. We've seen common salts, only like this table salt. You could bind hydrino or trap hydrino in that crystal, and then it will absorb ordinary hydrogen and release it. Hydrogen storage is very important right now for the hydrogen industry, hydrogen fuel cells and things like that. So it's a very good industry application of that technology. We submitted a new paper with Dr. Hagen, and this is the link to the paper. I invite you to go read all the details about it. So some of the other applications in addition to hydrogen storage is you can make energetic materials. We had shown previously that you can make like explosive compounds from common compounds that don't even have an energy release. And particularly shown taking silver shot and hydrating it and detonating it with 35,000 amps, you get 10 times the shock wave propagation intensity of TNT. And that's only 1% of the energy coupling into the shock wave. There's a validation report from Joe Rennick on our webpage. You're welcome to see that. So now we are working on a military contract with a military contractor, and I've filed some patents on taking that technology and making it into a device, and also the technology of how to scale it up incrementally in the lab as you move towards that device. And we have the technical drawings and the like, so that program is pretty much up to date in terms of our requirements to support it. Additionally, there's this very big interest in the government right now to make Star Wars laser like Reagan was pursuing, but there was no technology available to do that. And molecular hydrino can, in fact, enable an X-ray laser to shoot down ICBMs, because the rotational and vibrational energies of molecular hydrino can be in the X-ray region. Molecular laser, like the carbon dioxide laser, is the most powerful and most efficient lasers, and we would use the same phenomena with molecular hydrino replacing carbon dioxide. Rather than being infrared, it would be in the X-ray region, and it could burn a hole in an ICBM, for example. And it's small enough that you could have it space-based. So right now there are free electron lasers that they're working on that are as big as a football field. And obviously can't put that in space, but this you could. So you don't have the interference from the atmosphere and the like. You can make super magnets. This material is magnetic. So if you had a high density of these unpaired electrons, you could have magnets far surpassing those of ordinary ferromagnetic materials and the like cobalt, samarium, and even iron and things like that, and cobalt, and other types of alnico, and all kinds of different magnets. You make this magnet be vastly superior, and it does not require cryogenic temperatures like the superconducting magnets do, which are electromagnetic nature, but they require superconducting materials. You can make a photonic computer, magnetometer, sensors, and switches that I mentioned before because the fluxon linkage characteristic of the hydrino molecule. I mentioned common salts into hydrogen storage materials. There's a neutrino communication system I'll talk about, and you can image using neutrinos. You could make tritium. It turns out the world it doesn't have enough tritium even to run the ITER experiment over in Europe right now. And there's a way of making it with a reaction where the proton decays, makes a photoneutron. A neutron gets captured by a proton to make deuterium, or deuterium captures a proton, in this case, to make tritium. So then there's hydride batteries. We talked about energetic materials, and there's a way you make a hydride into a very energetic material as well. And then molecular hydrino can serve as a cryogen, coolant, buoyant gas, and the like. So phenomenal success with the. It's actually done. I think it's so comprehensive. It's everything from subatomic particle masses to everything cosmological. It matches absolutely perfect. Predicts, which is more important than anything in terms of the theory, is to predict technologies. There's some very disruptive technologies. In addition, there's a proton decay and production scenario that's absolutely vital to the whole evolution and mechanism of how the universe works, and even how sunshine is produced. So I have one of the predictions I have from the solution of the electron and the photon is that you can have a violation of Newton's third law, that is a reactionless force. And it turns out that free electrons can absorb photons, and when they do, and this is known, they have to conserve half the energy in terms of the increase in kinetic energy. You can't slow an electron down by absorbing a photon. You have to increase it because energy has to be conserved. So electrons moving directionally, it'll absorb a photon, and half that energy will go into increased kinetic energy. Half of it will go into the rotational energy of the electron in terms of its current. Then that gives rise to its Bohr magneton and magnetic moment, and its invariant angular momentum. So that's conserved. So angular momentum is conserved, energy is conserved, but linear momentum is not conserved. So you have a reactionless force, and that can create a mechanism of propulsion. And it turns out there's a paper that was published of all universities, Wuhan University, that actually shows data that I believe indicates that this effect can be very, very substantial. And from calculations, it can be extraordinarily substantial. And the resulting device would be it would result in an omnidirectional transmedium craft, no wings or exhaust. And to give you an idea, there is commercial equipment that exists that can make a compact million-watt pounds of thrust compared to 40,000 pounds of jet exhaust thrust of the F-35. And if you use it for interstellar, interplanetary transport, mobility, you can go pretty much anywhere in the solar system, let alone on Earth. And if you want to give it a sort of an order of magnitude of sort of what that would look like in terms of a craft, it would take you 2 days to get to Mars, and it's only using a fraction of its lift capability. That would you'd have to withstand 2 times the like right now you're standing on the Earth. If you got 2 times acceleration of gravity, that would get you to Mars in 2 days. If you could stand 4 times the gravitational acceleration of Earth, you get there in 1 day. But that's compared to 3 years for rocketry. And that takes something that's as big as a tall office. Basically, it's launching a tall office building, 11 million pounds, maybe like a 40-story or 50-story office building. And you need scores of launches to get the fuel out into space just to load it up before you took off. And then there's no way back. So it's kind of a very it's a lopsided comparison of this technology to existing technology, which I think will be antiquated very shortly once this is shown. And I'm very certain this will be shown to work. In fact, there's devices called laser accelerators that take just hydrogen gas in free space, and you shoot the laser in, and you get relativistic electrons in one direction, and it drags protons. And actually, H3 ions have a very, very long lifetime, and they're actually the ideal species for ion dragging, and they've become relativistic as well. So patents have been filed on this. Another prediction is the disruptive technology from the theory is that you can make a telecommunication system using neutrinos. Neutrinos is a form of light that doesn't interact with ordinary matter. In fact, there's about 50 to 60 billion neutrinos going through your body per square centimeter. So there's a huge number constantly streaming from the sun, from nuclear reactions occurring in the sun. And so they stream right through, and they stream right through the Earth. And neutrinos each have they're a photon of spin 1/2, corresponding to its angular momentum. Turns out molecular hydrino is spin 1/2 as well. It has a paired and unpaired electron in the same molecular orbital. This is what the projections of the angular momentum look like on its current density function on the membrane. It's a prolate spheroid equal potential energy surface that comprises the molecular hydrino. And what's very special about the hydrino is the cross section for neutrino absorption is 1 followed by 18 zeros, higher than that of baryons, which are protons and neutrons that make up nuclei, and they're also spin 1/2, and they are known to absorb neutrinos. So hydrino has a very special ability that it can be created in hydrino. Remember I said by the Raman data, I showed it shows you can get 2 photon absorption, and then you get a very unique situation in terms of emission. And there's other Raman data in the UV and others that show that you can get 2 photon emission as well, being shown by Raman by excitation with the ultraviolet laser. So you can use a laser to excite a rotational vibrational level of molecular hydrino, and then it'll emit a neutrino. So one of the K pathways, the E2 transition, is to emit a neutrino. And then the neutrino can travel through a vast distance, through everything, even the Earth. And it will, if it encounters another hydrino molecule, can be absorbed, and then it can, again, de-excite the rotational vibrational level by emitting 2 photons. It can be detected by a photodetector. And so this optoelectronic detector can then convert it into a telecom signal, which then can be received and processed. And so that comprises a telecommunication system that can eliminate satellites and telecommunication towers. And basically, you have your cell phone, and someone else has a cell phone, say in China, and you just talk, and that's it. You don't need anything else. And so it's uninterceptable, and it's not subject to electrical interference and things. It's vastly superior to existing electromagnetic transmission. So the other thing that's kind of interesting in everybody's mind right now is artificial intelligence. It turns out quite a while back, I actually solved the, I'll explain a little more about how the brain operates. And it turns out, so the question would be, is there something special about wet chemistry? Like humans have wet chemistry in terms of, and carbon chemistry, that matter, in terms of their ability to be a sentient being, it's enabling of being a sentient being. Do you need that for that phenomenon? And the answer is no, you don't. In fact, you could simulate that in silicon, and you probably could build it into hardware as analytical machines as well. But there's always been a question with the quantum. Quantum, it's kind of embedded in the old philosophy of quantum mechanics that your mind is controlling a reality and collapsing wave functions. And what is consciousness? It's a big theme in quantum mechanics. Schrodinger thought there's one universal mind. Penrose, I mean, imagine this. Quantum superposition and entanglement of neuronal microtubes gives you consciousness. I mean, talk about something really pretty wild out there. Wheeler thinks there's parallel mind universes, because if everybody's collapsing wave functions, why am I seeing the same thing you're seeing? Well, your mind's collapsing it and I'm delayed, which I'm experiencing now with the TV, incidentally. So my mind is not collapsing this wave function. So he thought there's some kind of parallel mind universes. And then there's this quantum view that human minds, as saying, create reality. And ultimately they're saying consciousness cannot be reduced to physical processes, and that's not true. It turns out you can solve exactly how the brain, the mechanism of the brain. It turns out that neurons aren't just interconnected, but they also propagate a series of potentials, like pulses, and there's a sequence of pulses, and there's the intensity of pulse and duration of pulses. All right. So I published a paper and a patent I've had issued on it. It explains if you're really into it, you can download these links or find these, and you'll find this very fascinating about the architecture, the algorithm, the structure, and how the brain actually encodes information and representations of information and how it processes that information. I'm positive you can simulate that on a computer. So it does have a future for SunCells and SunNet as a mesh network of information that's well, the SunCell is being telemetrically connected, and you can propagate that system on that. Same as you could get your Chat GPT on Google. This would be a good platform to launch that. Okay, major success in theory. We talked about that. Hubble Space Telescope. There's more impossible structures seen in the early universe. There's Hubble constant confirmation. There's a real crisis in cosmology now in terms of what the Hubble constant is. None of the models predicted what's observed. They're all breaking down. I predicted the correct Hubble constant, along with the acceleration and expansion of the cosmos, and the fact it's slowing, which is, again, very problematic for current cosmological models. And another very important thing is the mechanism of the regenerative cycle of the universe that evolves to expansion and contraction driven by proton decay and production. So other milestones: identity of dark matters, hydrino, dark matter decay signatures, proton production mechanism, photoneutron production signatures seen all over the cosmos. I'll go more into that. And the solar neutrino paradox solved. So major accomplishments, which pretty much brings the whole unification of the theory. Everything about the theory is being confirmed on all levels. So a little more detail on that. This is a very important development. This is a positron annihilation emission spectrum seen from space. The question is, what ultimately happens to a hydrino as it goes down to lower and lower states? So you have H1 over P. What happens when P is it goes to a minimum radius or a maximum P state? What happens ultimately to the hydrino? So it turns out the hydrino can actually cause proton decay. So the H atom can decay, and it can drive a decay and production cycle that ultimately is responsible for the expansion contraction cycle of the universe. The universe is converting matter into energy, and that's E equals mc squared, which everybody's familiar with. But as matter converts into energy, space-time expands according to the speed of light cubed divided by 4 pi times the Newtonian gravitational constant. So think of the sun causing a curvature in space-time like a dimple in a ball. Well, it's converting 5 billion kilograms of matter into energy, and that dimple will expand back out. Because ultimately, at infinite time and any kind of finite rate of conversion of the matter into energy, it has to disappear. So it does in fact occur. And if you take all the galaxies and all the stars per galaxy and the rate that's converting matter into energy, it does in fact give you the Hubble constant. So then what ultimately happens to the state of matter if it cycles from all matter to all energy over a trillion-year cycle, as that equations predict? And then how does matter then convert back into energy convert back into matter in the reverse cycle to make a complete oscillatory cycle? It turns out the hydrogen atom is the particle that links all that together. It turns out as matter converts into energy, it involves ultimately the proton decay into gamma rays. And then protons are produced in gamma ray burst. And the rate, for example, of those reactions matches identically what's required for that closed cycle. Moreover, more importantly, the signatures. There's a 511 keV gamma seen all over the universe. This is that from positron electron annihilation. That's produced as a decay product of proton decay. There's a neutral pion emission all over the universe. There's neutron capture reactions, so when neutrons are being produced. And then also from the sun, there's a muon electron neutrino emission that matches identically the hydrogen decay scenario, and it also solves the solar neutrino paradox. Solar neutrino paradox is basically they're saying muon neutrinos, and the standard solar model of proton-proton fusion requires being electron neutrinos, and muons are seen 3 to 1 to electron neutrinos, and this reaction predicts identically that. So it pulls together an enormous amount of astrophysical data, billions and billions of dollars worth of data. And it's so compelling because if you take the rate, I showed you the positron annihilation peak, 511 keV. If you take the rate that that's produced over the Milky Way galaxy and you multiply that to the period of the universe over which that matter of the Milky Way have to convert into energy, it matches identically. It turns out the predicted is 6 times 10 to the 42, and the Milky Way galaxy mass is 6 times 10 to the 42 kilograms, exact match. Moreover, in terms of laboratory experiments, it explains an enormous amount of data that has been really, really chaotic and had no congruent explanation or connections. Things like transmutation, neutron and energetic particle emission. And so an aspect of this proton decay, which is further more extreme, I mean, in terms of its importance is and significance, it turns out that proton decay can produce energy and power 1,000 times that of atomic and thermonuclear energy. It's equivalent to matter-antimatter annihilation. It's just an enormous amount of power that can be released, more powerful than anything in the universe. To give you an idea, the ultimate state of hydrino would be the P126 state. If you had a eraser, the amount of material on the end of a eraser of a pencil, that would be equivalent when it decays into gamma rays and from proton decay, the amount of power released in that would be equivalent to 2 Hiroshima bombs. So let's consider something that's again been sort of an outlier in terms of data and what on the lab, and that is cold fusion. And let's consider what the implications are for this proton decay and photoneutron production and neutron capture, which this whole scenario predicts from hydrino. So you have a chemical reaction, electron goes to lower states, and then ultimately the proton decays in the gamma rays, and that can produce neutrons. The neutrons can get captured, and you can produce isotope shifts, and you can produce. So you can change atomic number and you can change atomic mass of other nuclei. But let's take cold fusion. So it's easy to dismiss it. The reason being because they're saying they're getting nuclear reactions, extraordinarily high energy nuclear reactions in some material that will decompose at basically about the temperature you cook your turkey. So you need something, 100,000 times that kind of ability in terms of energy, the energetics to drive those kinds of reactions, much higher than that. So the other issue is they're saying they're getting proton and deuterium fusion with heavy nuclei. That would actually require energy. And then they're claiming there's proton-proton fusion, but it hasn't even been observed at CERN when you're smashing things together at 13 trillion electron volts. That's like millions of times more energy than in the sun. So let's look at how a scenario that can be easily accepted in the physics community. Let's say hydrino is proven. I give hydrino to some lab and they say, yes, hydrino is proven. And that's exactly what we're going to do. You can prove it. So now once you have hydrino, it matches all the signature to dark matter. There's the diffuse interstellar bands, the extreme ultraviolet crisis with this 10.1 nanometer continuum light from all over the universe, many signatures of hydrino all over the universe. And decaying dark matter is accepted for this ubiquitous 511 keV emission, neutral pion emission, and neutron production. It's accepted as a candidate for those inexplicable signatures from all over the universe. Grand unified theories require proton decay to exactly this reaction, positron and neutral pion, that ultimately gives you 511 keV. Photoneutron production, no nuclear reaction. Photoneutron production saves the standard model because it solves the solar neutrino paradox. Big thing for physics. neutron capture, beta decay, fission, spallation. There are no nuclear reactions. It's accepted that proton decay releases this massive amount of energy, 931 MeV, and it's known that proton decay would drive these reactions. And the reported data on cold fusion cells from reputable labs, military lab, big university labs, they're explained by the reactions and products above. So once you have hydrino, everything fits into place. So it's going to be interesting. And, RPE's just funded cold fusion now by $10 million. So it's getting interest in it. And their DOD did an assessment. They said, well, there's no theory, and they're sort of below TR0 because there's no explanation or no theme of why this should be even happening. And it makes perfect sense if you have proton decay by chemical process. And then once you have proton decay, you get all these nuclear reactions, and they match identically the data. So it's going to be interesting how that plays out. So next steps. Okay, so where we are, we have hydrino in a bottle. We plan to send hydrino samples to university and testing labs worldwide to prove its existence. That will deleverage any risk into the technology. In fact, I had one big power company tell me they would put more money into brilliant light than water flows over Niagara Falls if I could prove hydrino. Because if you have hydrino, then you've proven there's new energy source. And this is a phenomenally large energy release. Energy source, which basically, from the thermodynamics, you can use water as a fuel. You're going to get hydrino. You get 200 times energy burning just by proving the existence of that product. And moreover, on looking at the cells, so here's some chemicals. We're going to send this out to all the different labs. The other thing is we're running a series of hard tests on the SunCel, about 10 minutes each. I mean, don't want to run like an hour and blow something up and it damages the old cell. So we're going piece by piece testing all the different aspects that could go wrong first. And so far, it's not breaking. And that's just a joy to heart after all the hardships we had and challenges we had to come and solve along this path. So we're exposing it even to high oxygen concentrate, even air. That would destroy the electromagnetic pumps and the cell. And in all cases, the challenges we're putting it through now, 100% would kill it in the past, and it's not. So we're going to run more test systems, and we have out on the floor, we have about 6 made, ready to go online. Probably testing more this afternoon after the meeting, and we're going to go for an hour run. We have a lot of big companies. We're spinning them back up and again now. We just had a meeting with one big Silicon Valley companies. We had a meeting with one of the big power production companies. We have one of the big power organizations later next week, and then more and more in the pipeline. They all want to see like an hour run, and then they'll send their crew out to do independent power measurements. It's going to be very simple with the Thor power meter. You just put the instrument into the path of light, and it'll tell you how much power it's making. So we're also going to be testing this dual pool design, which I think is ultimately the end all of all the commercial designs we have that I can imagine. So we have 3 test stations. This is what they look like here, and this is another one. This is a station next to where you're viewing right now. So we're going to set up a 4th, and we have adequate manpower to operate that, and we have sufficient parts in the pipeline, and then we plan to validate the power with this optical power meters, which are back here, Thor S322C, and then we're going to host demonstrations for securing a strategic partner and raise capital for commercialization. In the past, we've achieved continuous plasma operation with no power. This is showing ignition off. Here's a link to that video. This was an open system. It was in the glove box. There's like a trillion different problems to solve before we got to where we are now. In fact, this material was silver and would have metallized over the dome in like a millisecond. So there's a lot that happened. We also but it ran with no input power. So once you get it hot enough, you can see it's yellow. Once it's yellow, it's about 1,300 degrees centigrade. So once it gets that hot, you don't need to have ignition power. There's enough thermal energy in the system to keep propagating the reaction from what we observed experimentally. We also tested that on a design we had prior. I was talking about that commercial window that we melted and sucked in. That also could operate on extremely low power. It turns out we got it down we got about 100 watts. There's basically no change from very high power down to 100 watts. And then once we went down to 50, then you can see a reduction in the light output. Of course, we didn't run that long term and get it as hot, but yeah, we were measuring the power and there's really no change until we went to very, very low power. So we're going to do more tests on that. And based on experiments I've done so far, we've reduced the power by a factor of 5, and it really didn't affect visually from what the any amount of the output power. So we're going to do more tests as we detail the operation, work out more of the parameter space, but it should not impact the economics in any regard, whether it runs under no power or not, because it's such a small amount of the overall energy balance. It really doesn't make a huge amount of difference, but will make a big difference in terms of impacting commercial packaging design. So we have a good relationship with one of the largest EPC firms, and in meetings with them pretty routinely, about bi-weekly, and they're on board to do all the commercial packaging, like the system engineering and the user interface, called the GUI, and the doing the programming, and then underwriters labs and things of that nature. So now we'll going next to the capital raise. So we've raised about $8 million in the last 4 years. It's kind of like what we need. It's just kind of raising what we need. And we have about 8 million in cash. The current burn rate is under 3 million. And we had another meeting with BTIG very recently. So we plan to work with them on a large capital raise, probably on the order of 40 million, to cover the dense receiver array, which we're ready to build now. It can be built in parallel, and then we do shakedown and packaging, and then do initial contracts in terms of contract manufacture with the big contract manufacturing firms like Foxconn and Sable, Jabil and Savina, and others. So it's and then, one other aspect is we have the EPC firms, and they're ready to go in terms of installation. They're saying they can just get a local permit and do installation like in a day. It would be grid connected, so there's no FERC regulation. So it's extremely easy to proliferate this technology. So it's a slog in terms of going through all the issues, and like 10 generations of technology, and then hundreds and hundreds of engineering problems, from the kinetics and the high power and transferring the power out of the cell, and how they convert it, and how it integrate with the business model and supply chain and safety and environmental and on to go through that. But then once the technology is in production, it could really just blow out everything. It turns out we made 250 kW unit. You need 60 million of those to make a terawatt. That's the entire peak generation capacity of the world. So with less than 60% of 1 year's car production, you could replace everything in the world. So it's once it happens, I think it's gonna blow out in terms of how fast this technology will proliferate. It's gonna be like vinyl records, It's just gonna be thrown in the dumpster, and people adopt it very, very quickly once it's available. So it's our timeline. We really haven't changed our timeline, because right now, as far as what we're seeing, the cell looks like I don't see really any engineering challenges to it right now. So I really, we're just kind of doing tweaks, and we got to do more studies, but we're pushing. I don't see anything's breaking. So I haven't, for the first time, I think, and since I started this program, I'm not staying up all night trying to figure out how to solve any particular problem. That the only thing I'm doing right now is trying to nail down all the IP and wrap everything up and get all the analytical, so we can prove the world there's hydrina. That's kind of the main thing, and make sure all the patents are tight on everything we're doing. So we're gonna do a private placement, as I spoke of, on the order of $40 million. We're going to continue spectral power measurements, spend specifications to the thermal photovoltaic suppliers, like there's Azure Space and Arzon Solar and other, to make this dense receiver array type of materials, and can make that package for us. And we'll have validations and technical assessments and things like that going on. We plan to do demonstrations. We're going to expand our corporate functions, and build up the management team. We're going to have some pilot systems for customers, and then we're going to do some field trials, and then eventually, as we get into manufacturing, go public and raise quite a lot of money to do a large commercial launch. So we got some, I guess we got some questions. What further benchmarks must be achieved to actually create the IPO or other liquidity event? What I've heard is we need a strategic partner, which means we got to do a demonstration, which means we have to do an hour run, and that means all the engineering problems have to be solved. Which I don't see any engineering problems to solve right now. I'm not saying there won't be, but right now it looks good. Reason for trade suspension, support bylaws for talking about taking such action. We'll come back to that. I'm the majority shareholder, so what Cooley said, I could do it, the board could do it, but it's in the best interest of the company. You want to sell your shares, you're damaging everybody else who's putting money into the company to keep it going and to retain any value it has now. In fact, people had bought shares long ago are basically relying on new shareholders to support them and my intellectual property that I keep putting in the company to sustain it. So it's not a bad situation, and it's kind of going to be the same no matter what. It's going to be sort of an all or nothing. I mean, you're either going to probably get 1,000 times where it is now, or you're not going to get nothing. But I think it's more favorable scenario that you're going to get 1,000 times. So I think it's in the best interest that we all kind of stay in the same plan, that we're going to try and get this thing public as quickly as possible, and then there'll be plenty of room to liquidate, and there'll be plenty of buyers for your shares at an extremely high price. I anticipate. Okay, do we have a 30-minute video of the SunCel showing power generation? We'll have a 30-minute video of the power generation as soon as we get to run it. Remember, we only got our certificate of occupancy March 1st. We weren't allowed to work here. We did a little bit of work out on that dock. I built a dock lift, or had it hauled in here, and we set it up so we could do some work outdoors. We were the only place we're allowed to work out in the cold. But now we're up full tilt, and I think we'll be able to get something here soon. Okay, more questions coming in. Please explain why people can be next to the SunCel with no production. Well, the SunCel, if it's 1,000 suns and you're away, it's a 3-inch diameter, or excuse me, 3-inch radius. So if it's 1,000 suns at the SunCel and you're 10 feet away, that's 120 inches. So that would knock the light down to about 0.6 suns, which about half the sun. Moreover, if you watch closely, they are not looking at it. I would not recommend looking at it. In fact, I don't think you could look at it. They're looking at it from the camera. So even when you see me looking at it up close, if you look closely, I'm watching it through I'm watching on my cell phone with the cell phone's camera. So distance is the most important, because reciprocal integer square drop off of the light, same as radioactivity. Looking at it from a camera and eye protection are kind of the ways that we handle the intense light. And please focus 100%. Okay, commercial, please focus 100% on SunCel commercialization, not in other technologies. This was for informative purposes. It's really nothing to do with brilliant light anyhow, some of them. So I just wanted to show you that there are some disruptive technologies who will have a major impact on the credibility of the company. Because one of the things about the hydrino is we get slammed because the theory predicts that you can have more stable states of hydrogen, which goes against quantum mechanics. Whereas, say, you take space drive or some of these other things, they don't really contradict the fundamental law. I mean, you could say the space drive has some impact on Newton's law, but it's an exception. You're not going to throw the textbooks away, but quantum you will. You're going to have to throw the textbooks away. Same with cosmology, you're going to throw the textbooks away. But some of these things, if you show their work, then there'll be massive amount of interest, and that'll give so much credibility to brilliant light. And of course, I'll be able to fund the whole thing myself. And it's something that fell out of the theory, and I think it's important to make something of that. Have you talked to Elon Musk and Bezos? Well, we have Jeff Wilkie from Amazon is a shareholder. I mean, I've talked to him in the past. He's a little bit conservative about involving the company. We talked to Amazon maybe like a week ago. They want to see like a longer duration run. Haven't talked to Elon Musk. People said well, I don't know. Well, there's issues there, but we do have contacts with potentially some contacts with the Trump administration, and then there's some plans to have one of their primaries, actually household name, come up here, who's very interested coming up here, and then that would give us a introduction to Elon Musk. Will the SunCel require an external power supply or work on batteries? Well, I talked about a 4 kilogram battery for startup, and the ignition system probably would probably not require much power, if any at all. But the SunCel, as you know, is an electrical device. So we would run, of course, charge any battery for restart. But during operation, it would run off its own internal power. Okay, can you provide a more color on the strategic partner? Well, we have oil companies, we have big mining companies, we have car companies, we have Silicon Valley companies, power companies. A lot of different companies are interested, and maybe some of them be investors, some of them there's some strategic advantage. I mean, there's not. I don't know if there's a lot they'll do. I mean, a lot of these companies aren't into low cost assembly and manufacturing, but it would be good for them from a strategic point to invest. And then, it could affect their businesses. Like, I think a good scenario would be that they use a lot of power and we can supply them very, very cheap power. Car industry is kind of interesting because you would need the batteries, would need the battery chargers and the like. And for Tesla, for example, if you have a liter of water, that's equivalent to a liter of hydrogen at 200 atmospheres. And that'll take a car 2,200 miles based on 50 megajoules per mole of H to H140. We're going to have more questions. Keep on coming. Okay, is a cap raise program, that is the time to time completion, and what is the pre-mount? Well, right now we're selling shares at 40,000 a share, which is a $5.6 billion market cap. I don't know if they approve of it or not. I mean, of course, I mean, who knows? Who knows? Depends on where we are. If we have a big demo, and then it's probably going to be worth $1 trillion. If we don't, it's going to be worth less. It's just there's a lot of factors there. Is the revenue from the military contract? Yeah, there is. Well, I'm not really pushing it for revenue, but if we do get it to work, one aspect is they may fund all our stuff, everything. They're interested in everything, even the other technologies. I'm very interested. And we wouldn't have to raise money anymore, equity money. Have you considered digital printing of digital printing, low cost using A1 as done by Divergent Tech? Well, I mean, we're going to look at how to make them, but right now we can make them really easily with cheap parts, just using conventional, just stainless steel. I mean, there's really nothing exotic about it, and there's nothing really complicated about the fabrication. It's just tubes and domes and different things. We have things from specialty parts. They really can't be printed. They're kind of a ceramic, and then you have metallized the ceramic, and then you have to braze in those. A big project to get all that technology, and there's only one company that has it. And we co-developed it with them, but there isn't anything really that can't just be made out of standard stock material, which is great. I mean, that was the whole point. So there's no supply chain issues, no exotic materials. It's all recyclable. Like, are the solar cells a limiting factor? No. In fact, everybody tells me that 1,000 sun concentration, there'll be overabundance of solar cells because you're getting 1,000 times more power out of the same size material. What material are you going to use for the geodesic dome? CPV, silicon? I don't know. It's a good question. We looked at, actually, the guy from Georgia Tech thought we could just use single junction silicon. I know there's an InGaAs, indium gallium arsenide, that Caltech and Cal Berkeley use, and I think MIT used the same. It's I was looking at low temperatures. like 12 degrees centigrade where there's really no visible light, but they got about 50% efficiency out of that. We're going to be running much higher sun concentrations. The efficiency is going to be much higher. But you can get 500 suns out of single junction silicon, and you run it. The nice thing is you can run it at high temperature. Like you run it like 100C, and it changes the band gap to match pretty much what 3,000-degree black body is. So it has some advantages and super cheap, and a lot easier to cool than some of the 3.5 materials. Will the company adopt a licensee fee model with no manufacturing self-service functions? Well, of course, we're gonna do whatever we can to make money. I mean, I think the military stuff probably be licensed out, and they're talking about we team up with some other companies and things like. Of course, we do that. Our core model for the SunCel is that we're going to outsource the manufacturing, installation, maintenance, and we're going to lease them, and then we probably charge an installation fee, which would pretty much cover the capital cost, which is very low. It's like $20 a kilowatt versus like 1,000 or more for like solar, and that's got like 20 years warranted. So it's good, it pays for itself, and in something like under a week. So the capital cost is kind of small. We probably get that back with the installation fee that we might charge, but beyond that, we just charge a per dam lease rate is kind of our model. Cars, we probably sell into cars. So if you had, let's see, you take the car market and we charge 20,000 piece, we'd end up with about $2 trillion a year in revenue based on current car production. And if you say, well, $20,000 seems like a lot to pay for. Well, it's not really a lot to pay for the power source, but nonetheless, even if you look at it in terms of the offset to consumers have to buy $20,000 worth of gasoline that they wouldn't have to buy, so they're basically getting it for free, and we can get about $2 trillion a year revenue from that with about, I don't think it's like 80% profit margin, and if we do the lease on site where we're leasing it rather than selling it, we're making about probably 95 or higher percent margin, but the car market is probably unique that we may have to sell them. But everywhere else, we're looking to lease. My question was not answered. Does suspension apply to exempt? No. If you have some issue with transferring it to, a case of will or something like that, or in a family non-sale, it's fine. Let's see, stock agreement. Oh, okay. Well, we can go over that. I'll send out something to shareholders, but we had Cooley look at it and they drafted the resolution. So I don't know. Does anybody really want to sell shares? I don't think it's a really good idea, to tell you the truth. I think it'd be very sad if you sell shares right now. What needs to be done for the SunCel to operate in motive environments? Actually, I'm building that. I have that worked out. I even have it worked out, and I filed patents on putting on a gantry, and you make like centripetal force and the like, that you can run it in space. And I'm looking at how to have it on a like a fighter pilot, fighter jet and things like that, firefighter drive it. Do all kinds of spins and things like that. So yeah, it can be adapted to pretty much any environment. And the PV is really robust. They put solar panels on. They shoot them up in rockets. And rockets is probably one of the most horrific shaking experiences you can go through. We actually know because we had Lockheed. They had that testing station across the street from us. We bought it. We bought the building from Lockheed, but they had this big thing that people said it'd knock your teeth loose. It's so much shaking. They actually built something that went down to the ground like 60 feet just to absorb all the shock from this thing that they put the satellite in there with the solar panels, and they simulated a launch. Right? It's not pleasant launch. It's really a lot of physical brutality on your body, and the same with solar cells. If you go through a solar cell, it'd definitely go through pretty much anything. I mean, solar cell through a launch, go through anything. Okay, I guess that's about it. So we got the voting. Sorry to keep you so long. Had a lot to cover. So let's see, we got election of directors. So we got myself, Randall L. Mills, David Bennett, Emilio Caza Chavez, and James Hardy. So all those in favor, aye. Aye. All those opposed, nay. So they get elected as directors to serve until 2026. So they're going to serve this 25-26 term. And 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 I guess that's it, right? Anything else? Amelia, got anything else? Okay, well, pleasure. It's a pleasure having you. The feedback was kind of tough to deal with, but we got through it. And I can hear myself in the other room. Everything I say comes back as an echo, but it's fine. And we'll take care of that next year. We probably should have rehearsed that, but we're so busy doing things. I just finished a presentation like little minutes ago. So, but I do appreciate your support, and you should be very enthusiastic about the company. I mean, it survived this move, and now we're up and going, and we're just going. And we got a great crew. We got a really good crew. I'm really happy. We didn't have any manpower to speak of for like a year, and it was really hard to get things done with all the packing and moving and uncertainty. But it all worked out well, and we have a beautiful facility, and engineering's working great, and we have Hydrino in a bottle. My God. I mean, that's it. The world's going to know there's Hydrino. We're going to make sure everybody knows in the world. And once there's Hydrino, then how people say the theory can't predict Hydrino, and everybody says there's Hydrino, and then that means there's a power source. So it's kind of game over in that regard. And we have beautiful engineering to move in and start taking advantage of that opportunity to take companies that will take us up on this. And I said this before, we should have been public years and years ago. It's just the quantum, they throw away the textbooks, and nobody wants to do that. But now they'll have to because there's actually a gas that we can give labs and prove Hydrino. It's the first time, I want to know, it's the first time we can do that on demand. That was very challenging, but we're there, and look forward to an exciting year. Thank you for participating and being supportive of us. Thank you.